So that means how to interpret this result. So if you pick at anywhere a thickness, and the thickness you designate as a T. Along the thickness, you assume the strain stress distribution. This is tau. Tau is constant. So that means at this position, this is a little bit wider, so the tau will be like this. This is even wider, the tau will be even smaller. Okay? So this is a tau here, this is a tau here, and this is a tau here. And that means because the thickness is allowed to change across the circumferential directions, so the tau won't be different. The tau won't be the same from place to another place. But the multiplication of the tau to T, we call the shear flow, must be the same. So that means you pick any point, any slice here, any thickness, there the shear flow, the Q, this quantity must be constant. Okay? Okay, so that is the first one. That is the first thing we talk about for the thin wall shaft. Here I want to make a very important comparison. For this thin wall shaft approach, you can see I have utilized this. The distribution of the strain stress across the thickness is constant. However, based upon our previous theory here, if you remember, for the hollow shaft, if this is torque, this is a maximum, and I told you earlier, this is the distribution of the strain stress along the hollow shaft. Based upon our previous conversation, the previous discussions, we know that the distribution of the strain stress across the thickness is not constant. It's linear changing, right? In the thin wall theories, we assume that the direction, the distribution of the strain stress is constant. So you see this theory has a little bit, yes. So that means for this theory, basically that is for convenient calculation based upon the follow-up information. But here we make the assumption this is constant, but that violates our the knowing fact. So that reason why I'm saying that for the thin wall, for the whole follow-up, the calculation, we have to make sure the thickness is small enough. Otherwise, this kind of serious assumption will give you not so accurate prediction. Okay, all the methods are developed based upon the applications, and all the method has certain the assumptions. That is the serious assumption here. And make this assumption good, the only way is to deal with the very thin thickness. So that means you can see if this one, thickness is very small, basically that little deviation in the linear variation is not really a big deal. Okay, so keep this in mind, and then next time coming back, we will follow up. I think there's 3 pieces and here. So that's kind of it, and we do have a few examples for this.